Hi. To observe reflection through polished surfaces is very usual to see in daily life. But today we are going to witness reflection, specifically total internal reflection, by a simple activity through unpolished surfaces, not very usual to see. For this, I have taken some simple material like a laser beam, a glass containing water, another glass containing water and a layer of oil, so that I have two different medium, or rather three different medium, one being water, oil and air. Each medium differs from another by means of the optical density. Oil is densest, followed by water, and the least dense is air. Here I have only two medium, water and air. This interface is the interface of separation between water and air, water being denser than air. So now I start with the activity. I have a laser beam. I will point a laser beam onto the water glass interface at different angles on the interface. Can you see the light beam has changed its path? The one which is coming out from the interface has bent by virtue of it coming from a different medium to another medium. Now what I do, I go on pointing the laser beam at different angles on the water interface. Can you see the moment I go on pointing the laser at water air interface at different angles, there is bending seen. The value of bending, the amount by which the ray bends, goes on changing as I go on increasing the angle of incidence and at some particular angle of incidence. Can you clearly see here the light beam, rather than going into the other medium, totally internally reflects at the water air interface? Can you see the incident as well as the reflected beam? In this case, it is not going at all into the other medium. Such a reflection taking place through unpolished surfaces at the surface of separation of the two medium, following two clauses to be understood. One, angle of incidence being greater than a critical angle for the medium, and light ray should go from a denser to a rarer medium. Here the light ray is going from water to air, water having refractive index 1.33, air having refractive index 1, thereby it suffers total internal reflection. To show you the same activity in a different manner, I have now taken two medium. In the two medium, I have one is the oil layer on the top and then is the water layer on the top. When I point laser beam at different angles, now the interface I am talking is the oil air interface. Oil being much denser than air, as well as it is being denser with respect to water at a particular angle called as angle of incidence. Can you now see the ray of light, the laser beam, is getting reflected at the oil air interface, following total internal reflection, that is reflection taking place through denser to rarer medium through unpolished surfaces. Finally, let me show you something more. The same water tumbler, I am now using the laser beam, and this laser beam is now inclined at an angle greater than angle of incidence in the glass medium. Can you see? We witness multiple layer reflections, and if we increase the column length of the liquid column, we will notice even more layers of reflection. So, please switch on light. So in this case, we learned that reflection can even take place through unpolished surfaces. Whenever light ray goes from denser to rarer medium, inclined at angle which is greater than critical angle for the pair of medium, the light ray suffers total internal reflection. Thank you.